Welcome to the first official lecture of LIS 805.99. In this session, we will explore the fundamentals of XML. So what is XML? Well, XML stands for Extensible Markup Language. It is a markup language like HTML. It stores and transports data, and it is both human and machine readable, meaning you can look at an XML document and you can read it yourself. You do not require a computer to interpret it for you. So what does XML do? Nothing. XML doesn't do anything. It is not a programming language, nor can it carry out commands. But that doesn't mean it has no value. In fact, XML is one of the most important technologies for libraries as well as other fields. Well, why? Well, because it carries data. Furthermore, XML is ideal because it simplifies data sharing, it transports data, it's adaptable for different platforms, which makes crosswalks, transformations, and migrations much easier. It also simplifies data availability. And it can also store data as plain text, which is valuable when using different software and hardware, in addition to the abilities listed above. Now that you know what XML is, let's take a look at the fundamentals of XML so you can begin to use it. This lecture will cover the structure of an XML document, XML syntax and well-formed code, as well as namespaces and validation. XML is formed in a tree structure, which contains elements, attributes, and text. An XML tree starts at the root element and branches from the root to the parent and children elements, and so on. In this example, you can see that the tree begins with the bookstore collection, then drills down into metadata about each book in the collection. We will cover more about this structure throughout this lecture and in the next couple weeks as well. This example provides a more extensive view of the XML tree you just saw, but with different metadata. It also includes some fundamental parts that are vital to all XML documents. First, we have the declaration. This must always be included at the beginning of any XML document. It will always be the first line. It declares which version of XML the document uses and the type of encoded characters used. Typically, you can expect to see version 1.0 and UTF-8, as these will display best on the browsers and they translate best. This is what I personally use. All of my colleagues use this, and this is what we will be using for the course. Next, we have the root element. This element encloses all other metadata within it. You can only have one root element. Everything will be enclosed within this one root element. All metadata can be traced back to this root element. And in this example, you can see that the root, which contains all of the metadata, is called records. And within the records, you have individual records that have metadata within them. Following the root element are the parent elements. They carry metadata about each individual record in this case. As the name suggests, it is the parent of the other elements. It does have children elements. In this case, the parent elements are the records, the individual records that are in the record collection. And they have children elements, which further describe them as parent elements. The metadata about each book record, or parent element, is stored in the child elements. Child elements carry specific pieces of metadata about the parent elements, and they are nested below the parents. So you have the root, which you could look at as a sort of family. So the entire family history would be enclosed in here. And then you have the parent, children. If the children have sub-elements, those would be indented a little bit. Then you can have as many elements as you would like, as long as they are nested properly. Now for an overview of elements. An XML element is everything from the beginning to the end of a tag. An element can contain text, other elements, attributes, combination of all of the above, as well as empty elements. They can be blank. You do not need to have anything enclosed within the elements, but usually you will. Requirements of elements include the following. You have your elements right here, and they have to have an opening tag and a closing tag. Those opening and closing tags both have the angled brackets, and then the name of the element is held within them. In this case, this element is named OCLC, and it has its opening tag right here, and then the closing tag. The closing tag will have the slash, and the value of that element will be right here. So the element describes what is in this this value right here. In this case, this is an OCLC number. We would not know what kind of number this was if this element tag didn't tell us what it is. It could say phone number, or it could say a price, or any type of number, or anything for that matter, but we wouldn't know what this value is unless the tag actually says that. Now let's take a look at attributes. Attributes provide information about elements. Elements can have attributes in the start tags. As you can see over here in these red boxes, anything in blue is an element. After the element, you have a space, and then the name of your attribute, an equal sign, and then quotation marks. Within the quotation marks, you will have your attribute value. The values describe the attribute, which describes the element. So in this case, the attribute is saying that the number of the record is 1. So this is record 1, and this is record 2. And the attributes must be in quotations. You can use double or single. I usually use double. That's kind of the standard practice, but you can use either. Both are perfectly fine. They work the same. You just have to be consistent and use the same type. You can't mix match them. And you can see right here, you can have the double or the single. Attributes store metadata. So as I just said, they store the metadata about the elements. And then the metadata about whatever resource you're describing will be within the values of all of these elements. Now we are going to dissect an attribute. The attribute follows the opening tag of an element. Use a space to separate the element from the attribute. And after you have the attribute, you have the equal sign, the quotations. Remember, you can use single or double. And then within the quotations, you have your value. You can also have comments. These aren't elements or attributes, they're just comments, but I wanted to throw them in here just so you know what they are. You can include comments in your XML documents as long as they are encoded between the angle brackets and an exclamation mark and 2 dashes. Then you can add whatever text you want as a comment. Typically, comments are used to add instructions, processing directions, or even something more simple like a note about something you want to edit, or maybe you wanted to put in a comment to say that you left off at a certain part of the code and you want to return to it to enhance it, or maybe make some changes to it. Now that you understand the contents of XML, we can explore syntax and rules. The syntax rules for XML are simple and logical, very easy to learn and understand. The main rule that you need to follow is your XML documents need to be well formed. And when an XML document is well formed, that means that it follows the syntax rules. So in short, being well formed means your XML follows syntax rules. If it does not follow syntax rules, it will not be valid and you cannot use the code. It just won't work. In order to follow proper syntax and become well formed, an XML document must follow these rules. First, tags must close. You have your opening tag and then the value of the metadata housed in between there, even though it's not actually pictured here. And then you have the closing tag. The closing tags will have this slash. Without it, as in this example, the tag will not be closed. It's just 2 opening tags with no ending tag. That will not make your code well formed or valid, and you will not be able to use it. Also, the tags are case sensitive, and they must match. You can use capital or lowercase letters as long as you're consistent. For example, you can have lowercase elements as long as the opening and closing tag both are lowercase, or you could have capitalized elements. You just can't mix them. A lowercase element with an ending tag that has a capital letter is not acceptable. It will not work, and Same if you start with an uppercase and then end with a lowercase. You could use a lowercase element and an uppercase element in your code. However, those are not the same things. If you query your data for lowercase elements, you will only get lowercase elements. It would not include this uppercase element even though it's the same tag name. But since it is not typed exactly the same way, they are different. You also need to have single or double quotes, and those must match. As I said before, these need to be consistent. You can use double quotes or single quotes, but you cannot mix them within the same attribute. That is not well-formed or valid, and your code will not work if you do that. In order to be well-formed, your XML documents also have to have properly named tags. You can create your own tags, but if you follow a schema, you will be limited to the established tags within that schema. Whether you create a new element or are using predefined elements from a schema, your tags must follow these naming rules. Tags can contain letters, numbers, and other characters. As you can see over here, you can start with a capital letter or lowercase letter. You can also include numbers. You can include other characters as well, such as an underscore. But there are a few exceptions. The naming rules are pretty easy. You can include anything over here, but there are a few things that you cannot include when naming tags. First, your tags must not start with a number or punctuation. It can't start with it, but as in the examples over here, you can still include a number as long as it is not in the beginning. Same with punctuation. You also can't contain spaces in your named tags. Remember that attributes follow elements, and in that structure you have an element, a space, and then the attribute, and then the attribute value. If you have a space in your element tag, you're basically telling the computer that you are about to define an attribute, but that's not what you're trying to do in this case. In this case, you're trying to have a space between book and one, but you cannot have that space. What you could do in place of a space is add an underscore or another character, or come up with a different name. You also cannot name your tags with XML, lowercase or uppercase. XML can only be in your script as a within the brackets in the first line in your declaration. You cannot name your tags with XML though. Properly nested elements are a must for well-formatted XML documents. An XML document is a structure, and if your structure is not well-formed, it will collapse and fall. Your XML document will always begin with the root, then the parents, then the children, then the grandchildren elements, and so on. You can add as much metadata as you like, as long as it follows this structure. In order to prevent confusion about what type of element to use, just ask yourself what element is your new proposed element going to describe. For example, if you want to add a subtitle to a record, would it be describing the collection, or would it describe a book, or would it describe the title? Well, it describes the title, since it's part of the title, so it would be nested under the title. And here you can see that all of the elements line up. They are all indented properly. And you can see that here, the lines. As long as they are if they are well formed, they will be nested properly. And you can always check the indentation to make sure that they are in fact nested properly. In order to be well formed, an XML document also must have proper entity references. These are more common than you'd expect, so keep an eye out for them. These characters need to be encoded because these characters on their own will trigger a command. If they are not properly encoded, they will prevent the document from being valid. In Oxygen, the XML editor we will use, a red squiggly line will appear under characters that need to be encoded. So if you ever forget to encode an entity reference, it's no big deal. The Oxygen XML editor will alert you, and then you can correct it. In addition to the squiggly line, it also gives you a warning down here. It won't tell you how to correct the problem, but it will tell you what the problem is. And here you can see a properly encoded entity reference. This refers to the ampersand up here. This one is encoded properly, this one is not. If they are not encoded properly, your code will not be well formed and it will not work. So now we're going to look at a few examples. Take a minute to look at these XML documents and try to see if you can find any problems with them. See if they are well formed. So I would suggest taking a second, pause the lecture if you want, and then come back and I'll give you the answers, if there are any. So the first problem here is this closing tag is missing its slash. So it actually isn't a closing tag. It needs the slash like these two, but since it doesn't have it, this is basically telling the computer that this title element starts here and just doesn't end. But it has to end before you can have these other elements. So simply adding the slash right before title, right in between the bracket, would make it well formed. But there's one other problem here. We have these two tags here which have spaces in them. Remember, you cannot have a space in your element names. You can only have a space when you have an element and then an attribute. The space is only for attributes. An alternative would be to use an underscore in place of a space. So what about this example? Take a second and take a look at this one and see if you can find any problems with it. So the first one is a little tricky. You might not have noticed it because it's not even there. It doesn't exist yet. First problem is this XML document does not have the XML declaration, meaning that it's not even an XML document. But after you include that, there's another problem. We have an entity reference that is not encoded properly. Remember, an ampersand is one of the characters that is that needs to be encoded. You would have the ampersand, then amp, then semicolon. This one, however, is not properly encoded, so your code would not work. Next, skipped ahead. Anyway, in this example, we have an improperly named element. Remember, you cannot begin elements with numbers. A proper alternative to this would be semester underscore 2016. That's fine. You can include numbers, but you cannot begin your elements with numbers. On to the final example. Is this example well formed? If not, what problems do you see in this one? So, actually, there are no problems in this one. Then this is a good example because it has the declaration, and then everything is nested properly, everything is named properly. There are no numbers or spaces or strange characters in these element names. We do have a good example of one that does have a character that is not a letter, have the underscore. We also have a character reference, an entity reference here that is encoded properly, unlike the last example. On to validation. A well-formed XML document is not the same as a valid XML document. An XML document is valid if it is well formed, it is linked to an external file that defines the semantic rules and legal elements and attributes for an XML document, such as a DTD or schema. We do use schemas in libraries, and this course will only focus on schemas, so you don't need to worry about DTDs. Also, in order to be valid, your XML code must also follow semantic rules, including proper naming tags and the proper order of elements. So what is a schema anyway, and what does it do? An XML schema describes the structure of an XML document, just like a DTD. An XML document validated against an XML schema is both well-formed and valid. Also, XML schemas are written in XML. They're extensible to additions. They support data types. And they also support different namespaces. In this example over here, you can see your XML declaration followed by all of the schema information. We are using MARC for MARC records. In this case, we have our MARC namespace right here. We have our schema instance here, which says we will be using the mark schema, and then we have the schema location, which says this is where that schema is. This is where the rules are for the schema. This is how the computer knows if your code is valid or not. It's checking these links, essentially. These are the three and most important aspects of validity: namespace, schema instance, and schema location. First up here we have the XML declaration. Following that, we have the mark namespace, which goes along with the mark elements. We're using the proper mark tags in this case, which is associated with mark. Then we have the schema instance and schema location. The schema will ensure that you are using the proper tags. So you cannot make your own up, like record. That cannot be used. You have to use mark record. And if you do not use the proper naming, the proper named elements, then your code will not be valid. It can still be well formed, but that will not make it valid. Remember, it has to go perfectly with the rules of the schema. Here's a more full view of a valid XML document. We have the declaration, the XML declaration at the top, followed by the schema namespace and instance, followed by the schema location. Following that, you have the bulk of the record. This is where your metadata actually lives. You have all of your defined elements here, all of the elements that are already named from the schema that you can use here. So you have all of your mark fields, and they are encoded as attributes. And then you have your indicators, and then you have the actual metadata. In this case, if you're familiar with mark records, the 100 field refers to essentially a creator of a resource. In this case, we have the person's name, followed by another element that describes who they are. So this says that this person is the author. Oh, also, notice the green box up here. In the Oxygen XML editor, this means the code is valid and well formed. If it were red, like with the red squiggly line from the entity reference we saw earlier, then you would know there's a problem. But if it's green, that's your green light, and it means your code's good to go. You can start manipulating it, transforming it, and uploading it. You can do anything with it at this point. Now here is an example of an invalid XML record. We still have all the proper stuff at the top. We have the XML declaration, we have our namespace, we have our schema instance and location. We even have mostly the proper named tags, except for this one in line 8 with the squiggle line under it. That is not properly formatted. As you can see with other element and attribute values, the character count has to be 3. You have to use 3 digits, even if the number is not a 3-digit number, like 6. It still needs to be formatted as 006, not 06, not 6, but 006. Just as in these examples, you have 007, 008, and 040. But since I took out a 0 there, that is not part of the schema. The schema will not allow it. Therefore, I get this red box, which means that I have a problem. Down here, it tells me what the problem is. It doesn't tell me how to fix it. It doesn't tell me to add another 0, but it does tell me that the problem is in this line, specifically with the 06 value. And that's one reason why Oxygen is so great, because it kind of holds your hand through it. It tells you what the problem is, and you just have to fix it. So it's a great lifesaver in this. So don't be worried that you need to proofread every little detail about your code, and you kind of should, but this does it for you, in a sense. So if you have any questions, please ask me, but also talk to your peers and visit some of the links I've included in the syllabus and Canvas. There is also a question and answer discussion board that you can use for any questions you want to ask. Maybe you even want to post a tip or something. Feel free to do that there. It is not required to post a question or answer a question, but you'll be surprised what you can learn in there, or somebody might ask a question you didn't think of yet. So take some time to check that out. And if you have no further questions, you can move on to quiz 1. Remember, you can use your lecture notes and any other resources for the quiz. The quiz is not meant to be tricky. It is meant to reinforce the lecture material and also for me to see that you actually went through the entire lecture and modules. The quiz should be an easy A, but if you don't like your first score, you can take the quiz again with no penalty. I will only keep the highest score. So don't be afraid to try a second time if you aren't happy with your results the first time. So good luck. And this concludes your first lecture.